Good morning, sir. Myself Enbad from 2nd ECE. My seminar topic is about PCM Generation Processes. PCM Generation Processes steps including sampling, quantization and encoding. Firstly, we want to know that PCM generation. Introduction to PCM generation. PCM refers to pulse code modulation. Pulse code modulation is a method used to digitalized representation of analog signals. PCM consists of three main processes called sampling, quantization and encoding. Understanding these steps is crucial for digital communication and signal processing. What is sampling? As we discussed in previous slide that PCM consists of three main processes. First one is sampling. Sampling is the process of measuring the amplitude of an analog signal at discrete intervals. This step converts a continuous signal into a series of discrete values. The sampling rate must be at least twice the highest frequency of the analog signal to prevent analyzing. Importance of sampling rate. The Nyquist theory states that the sampling rate must be greater than twice the maximum frequency. Sampling rate is greater than or equals to 2 FM. A higher sampling rate results in better representation but increased data size. Conversely, a lower sampling rate can lead to loss of important signal information. Second one, quantization. We want to know that what is quantization. Quantization is the process of mapping the sampled values to a finite set of values. This step introduces quantization error, which is the difference between the actual signal and its quantized representation. The number of quantization levels determines the resolution and fidelity of PCM signal. PCM refers to pulse code modulation signal. Types of quantization. In this second step quantization, again it divided into two types. They are uniform and non-uniform quantizations. Uniform quantization divides the amplitude range into equal intervals, making it simple to implement. Non-uniform quantization, like a law or mu law, compresses the range, providing better fidelity for lower amplitudes. Third one, what is encoding? Encoding transfers the quantization value into a binary format for digital transformation or storage. Each quantized level is associated in a unique binary code which allow for efficient data representation. Encoding schemes can vary with common methods including linear and logarithmic encoding. PCM signal representation. The pulse code modulation signal is represented as sequence or binary numbers corresponding to the unique quantized samples. Each number in the sequence represents a specific amplitude level of the original analog signal. This binary representation is crucial for processing, storage and transmission in digital systems. Applications of pulse code modulation. Pulse code modulation is widely used in digital telephone and analog recording systems. It plays a vital role in digital communications, including satellite and broadcast transformations. Pulse code modulation is also used in video compression formats, ensuring quality audio-visual content delivery. Advantages of pulse code modulation. Pulse code modulation provides high fidelity and accurate representation of the original signal. It is relatively immune to noise and distortion during the transmission. The, dig- the, dig- the digital nature of pulse code modulation allows for easy storage, processing, and transmission compared to analog signals. Conclusion: The pulse code modulation modulation generation process is essential for converting analog signal into a digital format signal. Sampling, quantization, and encoding are the key steps that ensure accurate signal representation. These three are the main steps of pulse code PCM, and quantization has two divided steps in that uniform and non-uniform. These concepts is fundamental in the fields of telecommunication and digital signal processing. Thank you.